You can drop a ball 100 times through a hole, and it will end up in the bin below the hole. But shrink the experiment down to the size of atoms, and it may end up in any of these bins. I'm going to explain quantum randomness. There are two types of unpredictable events: quantum randomness and classical unpredictability. Quantum randomness is inherently random, while classical unpredictability is causally determined. Let me use a thought experiment to describe the difference. A causally determined process looks like this. If a pool ball going 5 miles an hour approaches a bumper at an angle of 45 degrees, it bounces off at 45 degrees and continues at 5 miles an hour. The reason the ball goes 5 miles an hour at time 2, or t2, is because it's going 5 miles an hour at t1. Likewise, its direction at t2 results from the preceding direction at t1. Thus, t1 always dictates t2 because the laws of physics rule the system. After repeating the experiment 100 times, the result is always the same. Of course, this is an imaginary system where there is no friction and things bounce perfectly. On the other hand, a random quantum system behaves like this. In the first trial, a pool ball approaches the bumper at 5 miles an hour at an angle of 45 degrees and bounces off at 80 degrees and 2 miles an hour. In the next trial, the ball proceeds exactly like before, but bounces off at 120 degrees at 7 miles an hour. The experiment is repeated 100 times and the ball bounces off with these angles at various speeds. The attributes of the ball, as it approaches the bumper, have nothing to do with the outcome. Your instincts tell you that quantum randomness doesn't make sense. And for pool balls, I would agree. But certain things at the atomic level just don't follow causal determinism. Quantum indeterminacy dictates what appears to be erratic behavior. You can see this in the real-world example of single photon interference. When an individual photon of light is sent through a narrow slit, it strikes a sensor on the other side. You would expect the photon to always strike the sensor in the same place, but it doesn't. The first photon goes through and hits the sensor here, and the next goes through and hits it in a different place. Where will the next one go? You can't predict it because it's random. Nothing in the experiment allows you to predict the where of the next electron. If you send through 1,000,000 consecutive photons and plot where they hit the sensor, it looks like this. The take-home message is that where a photon is absorbed on the sensor is independent of its conditions prior to going through the slit. This is because of quantum indeterminacy. Please click the thumbs up icon if you like this video. Also leave your comments and questions below. Until the next video, remember humility. Thanks and joy.